On Monday, April 20th, a magnitude 7.4 earthquake struck Japan, and I noted that the quake only had a duration of 12.1 seconds. Immediately after saying such, I received a few emails from confused viewers in Japan who were quite certain that the shaking from the earthquake lasted far longer than that since they directly felt the earthquake. And their friends agreed too, with one particular email noting that they lived in Tokyo feeling more than 1 minute of ground shaking from the 7.4 quake. So in truth, was the earthquake 12.1 seconds long or more than 60 seconds long? Who is correct here? Surprisingly, both figures are correct, just there's another factor at play which causes the duration of an earthquake to be variable, with that factor being distance from the quake's epicenter. Generally speaking, the further away you are from an earthquake's epicenter, the longer the ground shaking from the earthquake will last for. This, of course, assumes two things. First, that by the time the seismic waves reach you, it is still strong enough to be detected by yourself. And two, that there isn't a lull in between distinct seismic waves reaching you. Confused why this is the case? Well, when an earthquake occurs, it automatically generates multiple types of seismic waves, all of which cause ground motion, and these propagate outwards in all directions at differing speeds. While the precise speed of each seismic wave type can widely vary, I have picked intermediate range figures to help illustrate this concept. The first and fastest seismic wave type to arrive is a P wave, which travels at a speed of around 6.5 kilometers per second. The S wave arrives next, traveling at about 60% the speed of a P wave with a speed of about 3.75 kilometers per second. Love waves arrive next, traveling at a speed of approximately 3.5 kilometers per second. And then Raleigh waves arrive after that, traveling at a speed of about 2.78 kilometers per second. Looking at these figures, you can easily see why the duration of an earthquake is variable depending on a person's distance from it. After all, the difference in speed between the fastest and slowest seismic wave types is 3.72 kilometers per second, meaning that every 100 kilometers seismic waves travel, the gap between the first and last arriving seismic waves further increases by about 20.59 seconds. I have created a chart to help illustrate this concept, showing the amount of time between the first and last arrival of seismic waves, indicating the 7.4 earthquake's perceived duration. Since Tokyo is located approximately 550 kilometers away from the magnitude 7.4 seismic event's epicenter, the gap between the arrival of the first and last seismic waves was 113 seconds. And this matches what the emails I were sent claimed. However, there's another factor to consider, although this is just a definitional one. Technically speaking, the duration of an earthquake measures the start and then peak seismic intensity of seismic waves and ends the measurement when seismic waves drop to 10% or less of their peak intensity and stay there. Thus, ground shaking strong enough to feel often continues to a certain extent even after a definition describes an earthquake as being over. The gap between the arrival times of different seismic waves and also the reflection of seismic waves off various structures further complicates this, meaning earthquake duration is not a great measurement to use. I hope this video clarifies this aspect of earthquakes. As a final note, I would like to thank this channel's patrons on Patreon and channel members on YouTube for supporting my work.